Notes 2.5, these are the last set of notes for the unit. We're not ready to test on the unit quite yet because this is really the bulk of what we're going to be doing. Now that we know how to add, subtract, multiply, and divide numbers in scientific notation, we need to actually be able to apply our information to word problems in scientific notation. That's the majority of what you will be tested on, just so that you guys know. So we are on the bottom of page 7. The notes start on page 7 on the bottom where it says notes 2.5. Word problems with scientific notation. Every time you have word problems, the first thing I want you to do is always underline key information. So, number 1, I'm going to read it out loud and I'm going to have you underline key information as we go through here. The outer wall of a large tourist attraction in Cambodia is about 1.1 times 10 to the 3rd meters long and 8.1 times 10 to the 2nd meters wide. Find the approximate area enclosed by the outer wall. I'm going to circle area because that's what I want to figure out. Now, from now on, I want you guys to figure out how to do this by replacing these numbers with easier numbers. So every time you have a word problem, you have to figure out what the operation is going to be by replacing it with easier numbers. So let's say that instead of saying 1.1 times 10 to the 3rd meters long, we're just going to say it's 2 meters long. I'm just replacing it with totally random numbers, okay? And then let's use 5 meters wide. And I want to figure out the area. Well, I know area, to find area, I just have to multiply the length times the width. So that means that the operation for this problem is multiplication. So we're going to write down that our operation is multiplication. Always identify what the operation is by using the easier numbers. So if I wanted to know the area, it would be 2 times 5, which is 10 square meters, right? But it's not 2 times 5. It's actually this 1.1 times 10 to the 3rd power times 8.1 times 10 to the 2nd power. Now you're going to probably want to write kind of small. I'm going to zoom in on here a little bit so that I have a little bit more room to write. You're going to just need to write small on your paper. Okay? So in order to find area, I just take the length and I multiply it by the width. And I know that the length is 1.1 times 10 to the 3rd power. And I also know that the width is 8.1 times 10 to the 2nd power. So I can go ahead and go through and group these together. So that means the area would be 1.1 times 8.1, right? And then multiplied by 10 to the 3rd power times 10 to the 2nd power. So now I have to figure out what is 1.1 times 8.1. So let's figure this out. 1.1 times 8.1. So 1 times 1 is 1. Again, 1 times 1 is 1. And then I bring the 0 down and I do 8 times 1, which is 8. And then 8 times 1, which is another 8. So I add all of these guys together right here. And I end up getting 891. Now, it's about 1 times about 8, so I should get about 8 as my answer, which means that my answer should be 8.91 when I multiply it together. So I get area equals 8.91. Now, since this is multiplication, I should add my exponent, so it's times 10 to the 5th power. The good news is this number is in scientific notation because the coefficient is between 1 and 10, so I don't have to do anything to adjust it. So my final answer is going to be 8.91. Now we always use area in square units, so square meters. And then I'm done with that question, okay? Hopefully. All right, and number 2, I'm going to underline key information as I read this out loud. The planet Mercury has an approximate mass of 3.3 times 10 to the 23rd kilograms. Mars has a mass of about 6.4 times 10 to the 23rd kilograms. How many times as great as the mass of Mercury is the mass of Mars? So that's what I want to figure out. How many times is great? And then I have to round the coefficient to the nearest tenth. So first thing I'm going to do is I have to always identify what is my operation. Okay, and anytime you have any word problems, I want you to write down what is your operation that you're trying to figure out. Any word problems that involve scientific notation. So I'm going to figure out what my operation is by replacing these harder numbers with easy numbers. I don't want scientific notation to figure out what the answer is. So I'm going to use easy numbers. So let's just pretend that the mass of Mercury is 5 kilograms. I know obviously that doesn't make sense, but we're using this to figure out an easier number, okay? And let's pretend like the mass of Mars is 30 kilograms. So the mass of Mercury is 5, the mass of Mars is 30. How many times bigger is 30 than 5? Well, hopefully you figured out in your head that 30 is 6 times as big as 5 because you just divide the two numbers to figure that out. So you do 30 divided by 5, which is 6 times as big. So that means that the operation here has to be division. Okay? Once you figure out this piece, it's so much easier to solve the problem. And you figure this out by using easy numbers, because once you put it in context, in a context that you understand, it's so much easier to solve. All right, now that I figured out what the operation is, I don't need to use this 5 or this 30, because again, that was just a tool to figure out what the operation actually is. So I have to divide my two numbers, but I have to figure out which number is larger. So I look at my exponents first, but they have the same exponent, so that's not going to help. So now I need to look at my coefficients. My coefficients are 6.4 and 3.3, so that means that this is the larger number. It also says how many times as great as the mass of Mercury is the mass of Mars. So Mars is the bigger number by the implication in the question. So I'm going to take 6.4 times 10 to the 23rd power, and I'm going to divide it by 3.3 times 10 to the 23rd power, which means that I get 6.4 over 3.3 times 10 to the 23rd power over 10 to the 23rd power. All right, now I have to actually do my division. So in order to do my division, I have to figure out how many times 3.3 goes into 6.4. Now, I can't do my division this way because 3.3 is a decimal. So I'm going to move the decimal place over here, but I have to move it over here as well to balance it out. So this becomes 33 into 64. Now, how many times does 33 go into 64? Well, 33 times 1 is 33. 33 times 2 is 66. That's too big, so it only goes in one time. So then I'm going to write 33 down here because 1 times 33 is 33. Subtract it. 4 times 3 is 1. 6 times 3 is 3. I can't go any further with this, so I have to add a decimal place right here and a 0 and bring down the 0. So now I have to figure out how many times, don't forget to put the decimal place right here as well, okay? How many times does 33 go into 310? Well, it has to be a large number because I know that 33 times 10 is 330, so it would probably be around 10. So I'm going to try 9. So 33 times 9. 3 times 9 is 27, carry the 2. 3 times 9 again is 27 plus another 2 is 297. So this will be this will go in 9 times. 9 times 33 is 297. Now I need to do my subtraction of this number right here, and I end up getting I get 13, excuse me. Bring down another 0, and then figure out how many times 33 goes into 130. Well, I know that it can't be 2 times because 33 is double to 66. So let's see what I get when I multiply 33 by 3. 33 times 3, 3 times 3 is 9, another 3 times 3 is another 9. So I think I could even possibly do 33 times 4. So let's see what happens when I do 33 times 4. Let's see what the answer is. So 3 times 4 is 12, carry the 1. 3 times 4 is another 12, plus another 1 is 13. So it's 132, which means that 4 is too large. That means I have to go in 3 times. 3 goes into 33. Sorry, 3 goes into 133 goes into 130 3 times. So then 3 times 33 is 99. Subtract it. It doesn't really matter what we get because it wants us to round to the nearest tenth. So 1.93, since this is the 100th, I can figure out that it's going to be just 1.9. So it's approximately 1.9 because this 3 says that this 9 should stay the same, times 10 to the, subtract your exponent since this is division, you get 10 to the 0th power, which turns out to be 1.9 times 1 because anything to the 0th power is 1. So the answer is it's 1.9 times bigger. Okay, now that was a lot of work and a lot of thought going into this problem. It always requires this much work and this much thought, okay? So make sure you're trying your hardest as you go through this. All right, you guys, number 3. First of all, it should say the Pacific Ocean is 6.4 times 10 to the 7 square miles. We're talking about the area of the Pacific Ocean, okay? And then it says that the area of the Arctic Ocean is 5.4 times 10 to the 4th square miles. And if you look at these numbers right here, the Pacific Ocean is huge, right? And so is the Arctic Ocean. But the Pacific Ocean is way bigger, and you can tell by the exponents. The exponent for the Arctic Ocean is only to the 4th power, but the exponent for the Pacific Ocean is to the 7th power, okay? And then the first question says to find the approximate sum of the areas of the two oceans. So I'm going to need to figure out how much it is when you do the sum, which means to add them. So I don't have to choose easier numbers to figure this out because it tells us what to do in the problem. But if it doesn't, you have to cross it off and use easier numbers. So the operation is addition. Okay, so I'm going to add my two numbers together. So I have 6.4 times 10 to the 7th power plus 5.4 times 10 to the 4th power. Well, in order to figure this out, I need to have my exponents to be the same because this is addition. So I can choose to either make them both 7s or make them both 4s. I'm going to make them both 4s. So that means that I have to adjust this number right here. So in order to adjust this number right here, I'm going to rewrite it as 6.4 times 10 to some power times 10 to the 4th power because I want it to change into a 4. Well, I need a 3 here in order to get this 7 here. So it's 10 to the 3rd power times 10 to the 4th power. I haven't changed my number at all. I'm just rewriting it in a different format, okay? And then I'm going to add 5.4 times 10 to the 4th power, okay? I cannot combine these together yet because I need to figure out what my new coefficient is going to be. Well, because this exponent is large, I have to move my decimal place to the right. So I'm going to move it over to the right 3 times. So 1, 2, 3, I get 6,400. So my new number is 6,400 times 10 to the 4th power plus 5.4 times 10 to the 4th power. Now they have the same exponent, so I'm allowed to add my numbers together. So I'm going to add 6,400 to 54. Okay, so I'm going to write this out. 6,400 plus, not 54, I meant to say 5.4, sorry. So I have 5.4 here. You need to line up your decimals. Well, 0 plus 4 is 4. Put your decimal place here. 0 plus 5 is 5. 0 plus nothing is 0. Carry the 4 down, carry the 6 down. So you end up getting 6,405.4 times 10 to the 4th power. Okay, but when I do this, I don't want you to erase your work. I want you to keep it. I'm just erasing it because I'm running out of room, okay? When I do this, this number is not between 1 and 10, right? So I need to make sure that it is between 1 and 10 by adjusting it. So this becomes 6.4054 times 10 to the 1, 2, 3, 3rd power times 10 to the 4th power, which means that my final answer is 6.4054 times 10 to the 7th power. Now I want to talk to you guys for a minute about the power of exponents because this right here, something really interesting just happened. So if you guys notice, the area of the Pacific Ocean is 6.4 times 10 to the 7th power. And the area of the Arctic Ocean is huge. It's still big, 5.4 times 10 to the 4th power. But notice the combined area. It's not that, it doesn't appear that much different than the actual area of the Pacific Ocean. 6.4 times 10 to the 7th power versus 6.4054 times 10 to the 7th power. It doesn't seem like that big of a difference because this is so much larger than this one is because it's to the 7th power versus to the 4th power, okay? Now the question is about how much larger is it? So, that's question B. How much larger is the area of the Pacific Ocean than the area of the Arctic Ocean? This time it doesn't tell us what the operation is. So we have to figure out what the operation is. In order to figure that out, we got to use some easier numbers. So let's pretend that the area of the Pacific Ocean is 10 and the area of the Arctic Ocean is 7. Let's just pretend. How would I figure out how much larger one is than the other? I have to subtract them. It's 3 larger, right? So that means that the operation that I have to do here is subtraction. So I'm going to subtract my 2 areas. So let's go ahead and do that. So I end up getting 6.4 times 10 to the 7th power minus 5.4 times 10 to the fourth power. Again, they do not have the same exponent, so I'm going to force them to have the same exponent, just like we did before. 6.4 times 10 to the some power times 10 to the fourth power. Again, I need a 3 here because 3 plus 4 is 7, okay? Minus 5.4 times 10 to the fourth power. So then this number right here, I have to move my decimal place over 3 times. I'm doing this fast because it's literally the exact same thing that we did in part A. I'm just doing it over again. So this becomes 6,400 times 10 to the fourth power minus 5.4 times 10 to the fourth power. So now I have to subtract my coefficients. So I have to figure out what 6,400 minus 5.4 is. Well, I have to line up my decimals, make this a 0. So this right here becomes a 10, right? This becomes a 9. This becomes a 9, and this becomes a 3. So 10 minus 4 is 6. 9 minus 5 is 4. 9 brings down. The 3 gets brought down. The 6 gets brought down. So you end up getting 6,394.6 times 10 to the fourth power. So then I have to adjust it. This becomes 6.3946 because it has to be between 1 and 10. Move the decimal place over 3 times, okay? So this becomes 6.946 times 10 to the third power times 10 to the fourth power. So your final answer is 6.3946. Okay, so now I need to adjust my number, and my number needs to be between 1 and 10. So this is going to be 6.3946. I moved it over 1, 2, 3 times, so it's times 10 to the third power, right? Times 10 to the fourth power. So that means that my final answer is going to be 6.3946 times 10 to the 7th power. So it's that many square miles larger than the Arctic Ocean, which is a huge number. If you actually figure out what this number is, it would be 6,394,6,000. So this number right here means it's 63,946,000 square miles larger than the Arctic Ocean. So much bigger. That's the power of these exponents right here. It shows you how big the number is. It's nothing. The Arctic Ocean is nothing compared to the Pacific Ocean. And then number 4, we're going to skip. So make sure that you really rewind and understand the stuff that you were asked to watch here, since it's a little bit shorter. Since we skipped number 4, use the extra time to make sure you truly understand what it is that we talked about in this.